and P of n plus 1 is, you know, is this. But this here is what you would get from the formula. So in other words, this formula is correct for n plus 1. Okay? So if it's correct for m, you know, P of m, it's correct for P of n plus 1. So we've proved the second step, the induction step. Okay? And now you have those two steps, the basis step and the induction step. You can then show it's true for any n. Because if it's true for P1, it's true for P2. And if it's true for P2, it's true for P3. If it's true for P3, it's true for P4, and so on. For all integers n. Okay? So you've proven you've proven P, your formula for P. You've proven that the formula you have for P of m is correct. Okay? Now, common sense, like I was saying a bit before, you cannot use a proof by induction unless you have that formula. And you need some formula like this to use it. Now, you may guess at a formula, and you can use proof by induction to actually show that that formula is correct. Because if your two steps, your basis step and your induction step, if they both work, then that means that your formula was correct in the first place. So you might guess at some formula and use induction to actually show that it's correct. Right? Now, that your guess might be wrong, in which case your two steps won't work. Right? But you may ask, well, where do these formulas, like I just pulled this out of a hat, right? I just threw it at you, I gave it to you. Where did it come from? Well, I had prior knowledge. Right? Like there are formulas, for example, formulas like the sum of the squares of the first n positive integers. So 1 squared plus 2 squared plus 3 squared plus n squared. There's a formula for that, and I think similarly for the cubes. Not too sure. Anyway, but if you're trying to find some formula along such lines, often proof by induction might be the way to go. I mean, there are other techniques, but proof by induction is useful. All right. Okay, so in other words, by using proof by induction, we proved that this statement here, that P of n, defined as the sum of the first big N positive integers, starting at 1, 1 plus 2 plus 3, equals this formula. Right? So we proved that. Okay, now an example from the text, a bit more complicated, but it's the same idea. It's in the context of mortgage payments. So you borrow say $P called the P for principal, the original amount of the loan. You borrow $P from the bank, let's say, or the mortgage company, whatever. Okay, and you pay every month, your mortgage payment, your monthly mortgage payment of $Y. Okay, so that, for example, over a 30-year mortgage, so it's a monthly payment, so you will make 360 mortgage payments each month over 30 years. Okay, and let's say the interest rate is fixed. That's the interest rate I. That's the annual interest rate. So let's say I will be 0.06. That's your I. Right? It means a 6% interest rate per year. Now we'll modify this. That's per year. We'll modify it so that you're paying interest every month. But it's just a complication. Okay. And this is the context for an example of inductive proof, and we will have a formula that will a formula for the size of the debt that still exists after T for time, T months. Okay. this formula will just be thrown at you. As usual with proof by induction, you have to have a formula, otherwise there's nothing to prove. So this formula for, it's called P of t, and t now is an integer, right? It's the number of months that you've been paying back the debt, starting off at 0. At time t0, your debt with the bank or the mortgage company is P, right? Because you borrowed the principal, as it's called. You borrowed that much. So PT suffix. It's in the next slide. But P suffix t, by definition, that is the debt that you still have after t months. Okay, and you'll be given a formula for that P of t, and you will try to prove that that formula is correct by a proof using induction, an inductive proof. Okay, that's the setup. That's the example. All right, now let's get into it. We need a bit of preliminary discussion for the moment. Instead of using interest rate yearly, we're going to use what's called a monthly multiplier. We call it M, and it's defined. I could put 3 bars here. It's defined as 1 plus the annual interest rate divided by 12. Okay, so each month you will multiply the remaining debt by this M. It's a sort of a interest factor, if you like, a monthly factor. So this is your interest rate per month, if you like. It's I. That's the annual interest rate. Let's say 6%. Divided by 12. So the remaining debt, you multiply that by M, and that will be the debt that's been increased due to the interest rate, right? The bank, the mortgage company, they're a business, right? Their business is money. They make money by lending money, and you have to. That's their profit is the interest that you pay, right? They're giving you a service. They're lending you money so that you can buy a house or a car or something before you have enough money to pay for it outright. Okay, so that's their service, but they charge you for that, and what they're charging you is interest. So long as the interest rate is not so crazy, like before there's legislation against it. In medieval Europe, for example, the Jews were notorious for this, but they were charging not like 6%, but 40%, which is one of the reasons why they were so disliked. Okay, so right, so you need this factor M. So it's 1 plus I, the annual interest rate, divided by 12, and we'll see this M increasingly. Okay, now. In this calculation, each month 2 things happen. One is the debt from the previous month is multiplied by M. Okay, so the previous month's debt is increased. The debt increases due to the interest rate. So you'll take the debt, call it P of t, of the previous month, where t is the number of months paid for so far, and you'll multiply it by M. So you'll increase it by this factor, 1 plus a little bit. Okay, so that will be the new debt, and then you subtract from that new debt. So it'll be, in other words, P of t plus 1. You'll subtract from that your constant monthly payment, which is Y. Okay, so. So that's how it works, and you'll be given, in the next session you'll see, you'll be given a formula for P of t. Remember, P of t is the debt that you have after t months. So t is your integer. So your P suffix t is equivalent to what we were talking about, P of n in previous previous session, right? Where n was your integer. In this case, t is your integer. But in this concrete context, t now is the integer that is the number of months that you've been that you've had the loan, that you've been paying out interest monthly payments. Okay, so I'll just move on directly in the next session.